Welcome to AP Physics Made Easy. My name is Eric Sampson, and what I want to do is help you get a 5 on your AP test. Now listen, AP Physics 1 has like the lowest pass rate of all the classes that College Board offers, but you know what? If you pay attention to my lessons, I think you'll be successful and you have a very good chance of getting a 5 on the test. So without waiting around, let's just jump into our first episode of this year, which is how to work with vectors. Now maybe you haven't heard of vectors before, so let's just get that out there. So there are two different kinds of measurements we work with in AP Physics 1. We tend to work with scalar quantities and we work with vector quantities. Now you're used to scalars. They're things we use in our everyday life. So scalars are things that have an amount associated with them, but not a direction associated with them. And these are things that you're used to measuring, things like volume, like gallon or liter. A 2-liter bottle isn't in any particular direction. It's just an amount. So volume, position, mass, time, speed, energy, these are all scalar quantities that have an amount and a unit associated with it, but that's it. But vectors are a bit different, and this is one of the things that a lot of students struggle with initially in AP Physics 1, so let's get you past that part of the year. So let's just look at two cars. I have one car that's traveling 40 miles an hour to the left, and I have another car that's traveling 40 miles an hour to the right. Now, when I talk about the scalar values here, they have the same scalar value. They have a speed of 40 miles an hour. So in scalar terms, they are identical to each other. But if you look at it, you can tell they are a little bit different from each other. So that is our vector quantities. So vectors have both a magnitude or amount, in this case 40 miles an hour, but they also have a directional component to them. This one's vector is 40 miles an hour to the left, whereas this one's 40 miles an hour to the right, and that's not the same thing. So the measurements that we'll deal with this year that are vector quantities are things like displacement, velocity, acceleration, force, and momentum. And these three here we'll deal with in the first unit of the year. But you'll get used to vectors, you will. And once you do, it really greatly increases the ease with which you approach problems in AP Physics 1. Okay, so here I have, this is my way of showing balls that are in motion. I use these little lines to indicate which way something is moving and the fact that it is moving. So all 4 of these balls have the same scalar quantity, and that quantity is 5 meters per second. 5 meters per second this way, 5 meters per second, it's all the same. But what we're going to do with vectors is we're going to distinguish the direction of a vector by using the symbol positive and negative. And this has nothing to do with quantity. It has to do with direction, which sometimes confuses students. So let's just look at how we would apply this. So unless we have reason to do otherwise, we're going to use this convention. We're going to say that up and right are positive directions. And we're going to say left and down are negative directions. So left is negative, down is negative. So we're going to put negative signs in front of these values here to indicate that they're not going in the same direction as the positive values here. And why do we use this? Who decided that up should be positive and left should be negative? Well, we just use it from the graphs, the Cartesian graphs that you're used to. If you think about the graphs you draw in math class, up is positive, right is positive, down is negative, left is negative. And that's the only reason we do it that way. But it is useful, okay? Now, so let's just look at the situation here. I have 2 carts. This one is traveling to the right at 5 meters per second. And by the way, we often put a little arrow above a value to indicate that it is a vector quantity and to indicate the direction of the vector. And this cart is traveling at 10 meters per second in the negative direction. Now, the negative sign associated with this cart, negative 10, does not in any way indicate that it has a smaller value. It just is telling me what direction it is. So negative 10 is not less than 5. Clearly, this one's going twice as fast, but the negative is telling me which direction it's going to. So you've definitely got to learn to stop associating negativeness with lessness. Okay, sorry, I did that one before. So when we add vectors, when we sum our vectors, the sum is referred to as the net vector. or like the net velocity or net force. And sometimes we use the word resultant vector. So the result of adding them up, what do we get? So when we're summing vectors, we have to remember to use the positive and negative signs. Otherwise, we're not going to get the right value. So here I have force vectors. So I have my little stick guy pushing this box to the right, which is the positive direction with 100 newtons of force. His friend is pulling it in the same direction, the positive direction with 200, but friction is acting against it in the negative direction with 50 newtons. So let's sum these up. So I'd say I have positive 100 plus positive 200, because they're both going in the positive direction, plus negative 50 because it's going in the other direction. When I sum this up, I get 250 newtons as my net force. So you see, it's really not that hard. You just have to pay attention to the directions and just be consistent. Now, we often use arrows to represent vector quantities. It's something you've got to get used to here. So it works like this. The direction of the arrow, indicates the direction of the vector. But the length of the arrow, and you've got to be consistent with this on the AP test, the length of the arrow indicates the magnitude of the vector. So I look here, I see this blue one, which is pointing in the negative direction, is twice as long as the one that's pointing in the positive direction. So it has twice the magnitude. So if this one was 10 meters per second in the positive direction, this one is negative 20 because it's going in the negative direction and it's twice as long. Now, if two or more vector arrows are added together, we can determine the magnitude and direction of the resultant vector using a technique that's kind of cool. So in this case here, instead of them going in the same plane, right, they're not going back to right or left. I have one going to the right, I have one going up. So what happens in this case? Well, it's really not that challenging. So to do this, we're going to use what's called the tip-to-tail method, in which I draw one arrow, and at the tip of this one, I'm going to put the tail of the next one, and I just add them up that way. So let's just see how this works. So I'm going to draw this one here, and then I'm going to take this one here, and I'm going to put the tail of this one at the tip of this one, like that. Okay? So then, if I want to draw my resultant vector, I start where I started, and I end where I ended. Because I could do this with more than just two vectors, although usually it would just be two. So I'm going to draw my resultant vector by starting where I started and ending where I ended. So there's my resultant vector. Now, if I want to know the magnitude of this, what would I do? Well, okay, so let's say this one is 4 and this one is 3. So I would use the tip to tail and do this. I would draw my resultant vector. How do I find the magnitude of this? Well, if you've done any geometry, which I think you've done by now, you know you can use the Pythagorean Theorem to do this. All right, so remember the Pythagorean Theorem just says this. It says you're just going to, what's going on here? Okay, I'm just going to say the resultant squared is equal to x squared plus y squared. All right, so let's just try this here. So my resultant is what I want. I don't want the square of it. So I'm gonna take the square root of both sides. So I just have r by itself. So that means it's going to be the square root of 4 squared plus 3 squared. Again, I think you've done this before. So I'm going to find the resultant is 5 meters per second. There it is. But what about the direction? So if I want to find the direction, I can use trigonometry to do this. So what I can say is, well, I remember SOHCAHTOA. And TOA means tangent. If this is my angle here, tangent is opposite over adjacent. So once I have that, I'll just put in my value. So I'm going to say that tangent theta is equal to opposite over adjacent, 3 over 4. And if I take the inverse tangent, then I'm going to get this. I'm going to get 37 degrees, which seems reasonable. Now, it's often useful to find the x and y components of a vector. So I have this vector here. So let's just say this thing has a velocity of 7.2 meters per second in this direction here, which is 33.7 degrees above horizontal. Well, it turns out if I want to work with vectors, I really need to break them down into like vertical and horizontal directions in order to work with them. Having them at an oblique angle like this doesn't really help. So what I'm going to do then is I'm simply going to say, well, I'm going to start where I start. I'm going to go over in the x direction until I've gone as far over in the x direction as that vector did, which this turns out to be 6 meters. 1, 2, 3, 4, 5, 6. And then to find my vertical component, I'm just going to go up. It's going to be 1, 2, 3, 4. So there's my vertical component. And so that's basically all you have to do to find your resultant vectors.